Hello everyone. Today we will begin our discussion of data representation with an overview of various different kinds of graphs and charts. So for all of the different kinds of graphs and charts that we'll be discussing in this video, we'll be using the same example data set. So a data set is basically a collection of data points or individual values that we are using for whatever piece of information we're trying to represent. So the example that we have here is ratings for what is presumably a pretty terrible movie. We have all of the different ratings listed out right here. There's 20 of these in total, if you were to count all of them up. And the idea here, when we're trying to represent something like this, I personally find that it's easiest to list them from smallest to largest, just because that helps you sort of organize your data a little bit better. But that's all based on your own preference for our purposes for this video. So once we have all of our data organized like this, we can make what's called a frequency table. And a frequency table we have an example right here. So this basically is just a table that tells us all of our actual values, which are whatever values appear in our data set. Note that that may not be every different value that is possible, but it's every value that actually occurs. And then we have our frequency, which is basically just how many times each of these different values appears in our data set. So rating 1, for instance, we have 1, 2, 3 people that rated this movie 1, so our frequency would be 3. We have 2, 1.5, so our frequency here would be 2, and so forth and so on. I would say that a frequency table is usually going to be a good first step for making a lot of these other different types of graphs and charts that we'll be discussing. So once we've got our frequency table made, we can make what we call a bar graph. So this is an example of a bar graph for this data set. So the way that bar graphs work, down here on the bottom, we have all of our different possible values for the rating. Note that in this case, we included values that are not values that actually appear in our frequency table. And then over here, we have the frequency on our vertical axis. And then we have heighted bars on each of these different numbers that represent the ratings, and the heighted bars represent the different frequencies. So let's say for 3, we have frequency 3 here is the height of our bar, and that goes with the frequency of 3 that we got in our frequency table. Notice that in this bar graph, we have one value out here, this 5, that we have a height of 1. We just have this one random bar at 5 that's separated from the rest of the data. We call this an outlier. It's a data point that lies away from the main body of the data. Closely related to bar graphs, we have what we call pictograms. So this is a pictogram for the same data set. Basically, the only difference between a bar graph and a pictogram is that instead of using heighted bars with a pictogram, we're using little pictures that we stack basically to whatever height for the frequency that we're looking at. Me personally, I don't really like pictograms as well as bar graphs. I think that they're kind of cheesy and not as easy to read, but for some things they might be useful. It's all up to what you're trying to use it for and what your preference is. Other ways that we have of representing this data set, we have a pie chart. So a pie chart, we are basically using slices of a circle to represent what proportion of our data, or what proportion of our frequencies go with data in different ranges or different values of our data. So when we're doing a bar graph or a pictogram, the alternate way that we could do this is instead of having the actual frequencies here, we could have the frequencies expressed as percentages of the total set of data. So in this case, we have 20 total data points. So for instance, a frequency of 5, that would be 25% of our total data. So instead of having, say, 1, 2, 3, 4, 5, we would have 5%, 10%, 15%, 20%, 25%. So for a bar graph, we always want to have, or we usually are going to want to have it expressed as percentages, maybe not always. And what I've done for this one to help simplify things a little bit is I've combined things into categories. So 1 and 1.5 are 25% of our data, 45% come from 2s and 2.5s, 25% from 3s and 3.5s, and 5% from that 1.5. Now, when we have something like this, where we are making categories based on numerical values, we refer to these as class intervals. And what we're doing by making these class intervals is we are taking a numerical variable and we are turning it into a categorical variable. So a categorical variable is a variable that may not necessarily correspond to a numerical value. For instance, if you had a grade distribution of letter grades on an exam, and you wanted to do just make a pie chart of A, B, C, D, and F, for instance. Those letter grades would be categorical variables. They don't have an actual numerical value necessarily that they go with, although one could argue that you're converting grades to numerical grades to letter grades. But say you just went directly to letter grades, for instance, you might not have a numerical value that goes with. This is an example where you might want to use a pie chart. You could also do a bar graph for this. Basically, just instead of having numerical values down here, you'd have whatever categorical variables you're looking at. The next type of graph that we'll look at is called a line graph. So this is a line graph for our data for these movie ratings that we've been looking at for our example. So the idea here is that you have heighted dots that you draw lines between that go with the frequencies for or values for whatever, in this case, rating it is that we're looking at. In reality, this type of data is probably not where line graphs are the most useful. Where line graphs really tend to be the most useful are when we are trying to track the value of a variable over time. So for instance, if we have gas prices and we're trying to track it over time at the beginning of each day for a month or something like that. That's a scenario where line graphs are particularly useful. The last type that we'll look at is what's called a histogram. So this down here is a histogram for our data set. And a histogram, you'll notice it looks pretty similar to a bar graph. There's a couple key differences that I'd like to draw your attention to. One of them is maybe a little bit of a more, just from something that you'd notice right away looking at it. The bars in a histogram are drawn touching each other versus in a bar graph they're not. Also down here, instead of having individual values of our variable, we have ranges. So 1 to 1.9, 2 to 2.9, 3 to 3.9, and so forth and so on. So what we're doing with a histogram is we're taking our data values from our frequency table and we're placing them into bins. So we would have, in this case, 1 to 1.9, we have this one bin that includes all the 1s and 1.5s, 2 to 2.9. The next is our next bin, and that includes all of our 2s and 2.5s and so forth and so on. Histograms are particularly useful for what we call continuous variables. So in this case, with the movie ratings, we're dealing with what we call a discrete variable. In other words, our movie ratings in this case can only have values of something 0.0 or something 0.5 basically in that 1 to 5 range. So there's fixed values that our variable can have. We would call this a discrete variable. A continuous variable is one where you have a variable that can take any value, perhaps within a specified range, but say that we had something like this where you could have a rating of 1.53789. that would be a continuous variable. You could pick basically anything in this range, and it would be valid. This is where histograms are particularly useful. When we have something like that for a continuous variable, it helps to have an endpoint convention, and that's basically saying where we have a data point that's right on our dividing line from one bin to the next, which bin do we put it in? Thank you for watching, and if you have any questions, I am of course happy to help.